Hello and welcome to the second day of 1.2. Today we're going to continue talking about measuring spread, and remember that's about how far apart the data is within a data set. Two new measures of spread is variance and standard deviation. Variance is s squared, where standard deviation is s. Now there are a few formulas. This is the long way to write it, where we take each x value and subtract x bar, which is the mean. So each value, subtract the mean, and square that. Now that gives us how far each data point is away from the mean squared. Now we add all of those values together and divide it by one less than the total number of values in your data set. That gives you s squared, or the variance. Or more compactly, we can do 1 over n times the sum of all of the x of i's minus the means squared. This is the same thing as writing what's up top here. Now to find the standard deviation, what we do is we take the square roots of both sides to get s equals the square root of the variance. Now let's try to do this. Let's put these values into our calculator under L1 for the females. It's going to take a second for my trusty calculator to pop up. All right. Now I'm going to go over to L1 once my trusty calculator starts working. All right. I'm going to clear this data set out. And I'm going to have the data points 5, 7, 10, 14, 18, 19, 25, 29, 31, and 33. All right. Now, if I want to find the standard deviation, what I can do is the first thing I want to do is go to L2, and I take each x value, subtract it from the mean, and square it. So I can say this is going to be my L1 values, which I do second one to get L1, minus the mean. Now to find the mean here, I need to quit out. And if we hit stats, edit, nope, let's try that again. Stat, calc, move over to one variable stats. And now you don't need L1 because L1's the default, but we can type it in anyway. And we can find that the mean is 19.1. So when I edit this, if I go back up to L2, I'm going to do L1 minus 19.1, and then I'm going to square that value. And this gives us all of those values of the x value minus the mean squared. Now what our formula tells us to do is we want to sum them all up. So to do sum, we hit second, stat, move over to math. Sum is number 5. We're going to sum up L2, and that's the sum of those values, which was the numerator of our equation. Now we want to divide that by the number of values, which is 4, 5, 6, 7, 8, 9, 10, and subtract 1, so 9 values. That gives us a variance of 102.5. Now if I want to find the standard deviation, I just square root that value, which is 10.1. Now, our calculator makes it easier than just using those formulas, but those formulas give us a better idea of how we come up with the numbers. If I ever ask you to just find the standard deviation or the variance, what you do is you hit stat, move over, second stat, move over to math, and you can see number 7 is standard deviation. Standard deviation of L1 will give us 10.126. which is what we had here. Or we can do the same thing with second stat, go over to math. Now variance is number 8. So if we click on number 8 of L1, that's going to give us 102.5. That's the easiest way to get the mean or the standard deviation and variance. You can also hit stat, go over to calc, one variable stats of L1 to give us, you can see that S of X is 19 or 10.1. This right here is our standard deviation. One variable stats doesn't give us our variance, but we can just square this number to get it. All right. Now, properties of standard deviation. We call standard deviation that little s. It measures spread about the mean and should be only used when the mean is chosen as the center. S equals 0 only when there is no spread or variability. This happens when all of the data points or observations have the same exact value. Otherwise, the standard deviation has to be greater than 0. As observations become more spread out, their S gets larger. S, like X bar, is not resistant. A few outliers can make S very large. Now, when you're choosing a summary, the 5-number summary is usually better when you're than the mean and standard deviation when you're describing a skewed distribution. So you use the 5-number summary, which includes the median, when you're dealing with a skewed distribution or strong outliers. You use X bar, mean and standard deviation, with symmetric distributions or free of outliers. All right. So now we're going to move on and see how the data points are affected by a linear transformation. So take a second, plug these values into your calculator and find the mean, median, range, IQR, standard deviation, and variance. You can pause it, and I'll let you go through it. All right, here are the values for this set of data. Now do the same thing for 4 plus x. So you can go to L2 and just do 4 plus all of these values in L1, or you can just type in those data points. All right, hopefully you found them. Now, if I uncover them, you'll see the median and the mean both went up by 4, but the range, IQR, standard deviation, and variance stayed exactly the same. So if I take my data points and move each of them up 4, these values over here that represent the spread doesn't change just if we add a value to each of the data points. However, the centers will change. So, if we just add any point to all of the values, the centers change, but the spread does not. All right, now take a second and multiply 3 by each of those original values and see what you get. Now, these are the answers. Now, if I took the original data set and put it in here, I'll move this down. Hopefully I can move this down. Maybe I have to go to my mouse. All right. All right, the original data set's on the bottom. You can see that the median is multiplied by 3, the mean is multiplied by 3, the range is multiplied by 3, IQR, standard deviation, but the variance isn't. The variance is multiplied by 9. Now do the same if we do this linear transformation. We take 3 plus 2x times all of the original values, and we get these. Now find all of these values for that. Here are our answers. Now to find 19, you just take 2 times 8, add 3. Same with the mean. Now for the range, it's just double, because the range is not affected by that 3. Same with the IQR, same with the standard deviation. But the variance isn't multiplied by 2, the variance is multiplied by 4. What do you notice about the 2 to multiplying by 4 and the 3 is multiplied by 9? Hopefully you see that the variance, you're multiplying by the square of your slope on your linear transformation. All right, so here is a summary of what happens in a linear transformation, a plus bx. So if, the mean and median is just a plus b times the old measure of center. For range, IQR, and standard deviation, you just multiply the slope times, this says range, but it should say IQR, the old IQR. Oh, and variance, we have to multiply it by the slope squared times the old variance. All right, so what does this mean? Well, if I am going to convert inches to centimeters, I have to multiply each value by 2.54 in my data set. How is the mean affected? Well, I take the old mean and I multiply it by 2.54. Now, how is the variance affected? I'll take the old variance and multiply that not by 2.54, but 2.54 squared to get the new variance. What about if I'm going to convert from Celsius to Fahrenheit? How does this affect the standard deviation? Well, I take the old standard deviation and multiply it by the slope, 9/5. How does it affect the range? Well, I take the old range and multiply it by 9/5. How does it affect the mean? Well, I take the old mean, multiply it by 9/5, and now I have to add 32 because the mean is affected by the y-intercept. All right, hopefully that makes sense. Good luck with the homework.